Intro. Right now, 400 million miles from Earth, a storm larger than our entire planet has been raging for over 350 years, longer than the United States has existed. The Great Red Spot on Jupiter generates winds of 400 miles per hour that could obliterate everything in their path. Yet this cosmic hurricane maintains perfect stability in an environment of absolute chaos. But here's the terrifying truth. This ancient storm is dying, shrinking at 580 miles per year, and when it finally disappears, Jupiter will never be the same again. Did you know that we're literally watching the death of a weather system older than human civilization unfold in real time? The mystery storm discovery. When Juno reached Jupiter's North Pole in July 2016, mission control went dead silent. What they saw defied every computer model, every prediction, every theory about gas giant atmospheres. 8 massive cyclones, each the size of Texas, were arranged in a perfect geometric pattern around a central hurricane that could swallow Earth whole. These weren't ordinary storms. They were maintaining positions with mathematical precision that seemed almost artificial. The southern pole revealed an equally bizarre sight. 6 cyclones locked in a pentagonal formation, spinning at 100 miles per hour while staying 52 degrees Fahrenheit cooler than their surroundings. What terrified scientists most was the stability. On Earth, hurricanes last days or weeks before dissipating. These Jovian monsters have been maintaining their cosmic dance for years, possibly centuries. The Deep Space Network tracking data showed these cyclones weren't just surface features. They were connected to atmospheric rivers flowing thousands of miles deep. It's as if Jupiter operates by entirely different laws of physics, where chaos organizes itself into patterns that shouldn't exist according to everything we understand about planetary atmospheres. Largest eruption recording. The microwave radiometer aboard Juno penetrated deeper into Jupiter than any instrument ever had, and what it found was absolutely mind-bending. Hidden beneath the cloud tops were towering atmospheric structures that scientists dubbed steeple mountains. Invisible giants of gas and energy extending 1,800 miles down into the planet's interior. To comprehend this scale, that's 270 times deeper than Earth's Mariana Trench. These weren't physical mountains but massive atmospheric belts that plunge into Jupiter's core like cosmic elevator shafts. The gravitational measurements from Juno's 54th flyby on September 7, 2003 revealed the shocking truth. Jupiter's atmosphere doesn't end where we thought it did. Instead, it blends seamlessly with the planet's interior in a way that violates our basic understanding of planetary structure. The spacecraft used Jupiter's own gravity as a scanning tool, measuring velocity changes as small as 0.01 millimeter per second from over 400 million miles away. What emerged was a 3-dimensional map of a world where the boundary between atmosphere and interior simply doesn't exist. Jupiter isn't just a gas giant with a solid core, it's a fluid, chaotic system where atmospheric storms reach depths that would take you from New York to the center of Earth and back again. Largest eruption recording. Juno uncovered evidence of atmospheric eruptions so massive they make Earth's most violent volcanic explosions look like firecracker pops. The Great Red Spot, that iconic crimson hurricane we've admired for centuries, plunges an astounding 300 miles below the cloud surface, deeper than the distance from Earth to the International Space Station. But this ancient storm, observed since the mid-1600s, is just one player in a symphony of atmospheric violence. Smaller storms reach 60 miles down, while others extend over 200 miles into Jupiter's interior, creating a labyrinthine network of atmospheric chaos that operates in 3 dimensions. The energy scales involved are beyond human comprehension. These storms have been raging for millennia, powered by forces that dwarf anything in our solar system. NASA's precision instruments detected atmospheric explosions that release more energy in a single event than Earth receives from the Sun in an entire year. The Deep Space Network measured these eruptions with incredible accuracy, revealing that Jupiter's weather system isn't just more violent than Earth's, it operates on completely different principles. While our storms are temporary disturbances in a stable atmosphere, Jupiter's storms are permanent features of a world in constant atmospheric rebellion against the laws of physics as we understand them. Jupiter's magnetic field. The magnetometer investigation aboard Juno revealed that Jupiter's magnetic field is not just stronger than expected, it's completely alien in structure. Jack Connerny from NASA's Goddard Space Flight Center led the team that created the most detailed magnetic map ever made of another planet, using data from 32 orbits around the gas giant. What they discovered was terrifying. A magnetic field more than twice as powerful as models predicted, with an irregular, chaotic structure unlike anything seen before. The most unsettling discovery was the Great Blue Spot, a massive magnetic anomaly at Jupiter's equator that's drifting eastward at 2 inches per second, completing a full lap around the planet every 350 years. This isn't just a magnetic field, it's a cosmic scar. Scientists believe meteorite impacts billions of years ago modified Jupiter's magnetic structure, which is now frozen in a superconducting core, like a permanent record of ancient cosmic violence. Even more disturbing is the discovery of secular variation. The magnetic field is changing over time, something previously only detected on Earth. Jupiter carries the magnetic memory of collisions that happened when the solar system was young and chaotic, making the planet a living museum of cosmic catastrophes that shaped the worlds we see today. Atmospheric water mystery. Juno's microwave radiometer has been conducting the ultimate planetary autopsy, using 6 antennas to X-ray hundreds of kilometers below Jupiter's cloud tops. And what it's finding about water content is rewriting the textbooks on planetary formation. For decades, scientists assumed Jupiter formed beyond the frost line where water should freeze and accumulate in massive quantities. The planet should be soaked with water vapor, but Juno's measurements are revealing a distribution so patchy and unpredictable that it's forcing us to reconsider everything about how gas giants form. The water mystery cuts to the heart of solar system formation theory. If Jupiter's water content doesn't match our models, it suggests the early solar system was far more violent and chaotic than we ever imagined. The implications are staggering. It could mean that planets don't grow peacefully by accumulating material, but are forged in cosmic disasters that fundamentally alter their composition. Juno's deep atmospheric scans are essentially performing cosmic archaeology, peering into Jupiter's interior to read the story of its formation, written in water vapor concentrations. What they're finding suggests that Jupiter didn't form where we think it did, or that massive collisions during its formation scattered water in ways that defy current planetary formation models. The planet is keeping secrets about the early solar system that could change our understanding of how Earth and every other world came to exist. Polar cyclone dynamics. The poles of Jupiter are cosmic madness manifested in 9 cyclones arranged in perfect geometric symmetry around the North Pole, 6 cyclones forming a pristine pentagon around the south. NASA's navigators have been tracking these atmospheric beasts with surgical precision since Juno's arrival in July 2016, and what they've discovered violates every principle of atmospheric dynamics we know. Each cyclone spans nearly the width of the continental United States, spinning at incredible velocities while maintaining their positions like cosmic clockwork. On Earth, storms are temporary chaos that forms and dissipates. But Jupiter's polar cyclones have been locked in their geometric dance for years, possibly centuries. They resist change with an almost intelligent stubbornness, forming what scientists describe as a private club that seem to resist new members. The data reveals these aren't just surface storms, they're massive atmospheric columns extending thousands of miles into Jupiter's interior, connected to the planet's deep atmospheric rivers like cosmic pillars holding up the sky. The precision of their arrangement suggests forces at work that we don't understand, atmospheric dynamics operating on scales and timescales that make Earth's weather look like child's play. These cyclones are essentially atmospheric monuments, permanent fixtures in a world where chaos has somehow organized itself into mathematical perfection that shouldn't be possible according to everything we know about fluid dynamics and planetary atmospheres. Jupiter's composition and structure. Juno's gravitational measurements have shattered our most fundamental assumptions about Jupiter's interior structure. The spacecraft has revealed that the king of planets doesn't have a solid core like textbooks claim. Instead, it harbors a fuzzy core made of rock fragments and metallic hydrogen scattered throughout its interior like cosmic shrapnel. This discovery is revolutionary because it suggests Jupiter's formation was catastrophically violent, likely the result of a massive collision that occurred during the early solar system's chaotic youth. Juno acts like a cosmic detective, using tiny velocity changes to map the distribution of mass inside Jupiter. By measuring gravitational variations as small as 0.01 millimeter per second from hundreds of millions of miles away, scientists can essentially see through the planet's layers. What they're finding is that Jupiter's interior is not the neat, layered structure we expected. It's a chaotic mixture where different materials are scattered in patterns that speak of ancient violence. The implications are staggering. If Jupiter was fundamentally altered by a collision, it means planetary formation in our solar system was far more destructive than we thought. Planets aren't just peaceful accumulations of cosmic dust and gas, they're the survivors of cosmic wars fought billions of years ago, carrying the scars of impacts so massive they can reshape entire worlds and alter the course of planetary evolution forever. Great Red Spot Analysis. The Great Red Spot has been Jupiter's most iconic feature since telescopes first revealed it in the mid-1600s, but Juno's close-up analysis has unveiled a storm so complex and alien that it's forcing us to redefine what we thought we knew about atmospheric phenomena. This isn't just a hurricane, it's a 300-mile-deep atmospheric monster that extends from the cloud tops down into Jupiter's interior, further than the distance from Earth's surface to the International Space Station. Juno's instruments have mapped the storm's three-dimensional structure, revealing a spiraling tower of gas and energy that operates like a cosmic tornado lying on its side. The storm's winds reach speeds that would instantly destroy anything on Earth, while temperatures and pressures at its base approach conditions found in the cores of rocky planets. What makes the Great Red Spot truly terrifying is its permanence. This storm has been raging continuously for over 400 years, possibly much longer. It's a weather system older than most human civilizations, powered by energy sources we're only beginning to understand. Juno's data reveals that the spot is connected to Jupiter's deep atmospheric layers, drawing energy from the planet's interior heat like a cosmic engine that never stops running. The storm is essentially a window into Jupiter's soul, a permanent scar in the atmosphere that reveals the violent, chaotic nature of a world where weather operates on scales and timescales that dwarf anything in human experience. Jupiter as planetary protector. Juno has documented Jupiter's role as our solar system's bodyguard in terrifying detail, revealing a cosmic protector that's constantly under siege from interplanetary debris. The spacecraft observed a meteor impact in April 2020 with an estimated mass of 250 to 5,000 kilograms, just one of countless projectiles that Jupiter's massive gravitational field captures before they can hurtle toward the inner solar system. Without this cosmic vacuum cleaner, Earth would face regular bombardment from asteroids and comets, making complex life nearly impossible. Juno's observations show that Jupiter is essentially sacrificing itself for the rest of us, taking hit after hit from space rocks while we orbit safely in the inner solar system. Each impact creates massive explosions visible from hundreds of millions of miles away, releasing energy equivalent to multiple nuclear weapons. The planet's gravitational influence extends far beyond its physical size, reaching out like invisible tentacles to snare dangerous objects that might otherwise threaten Earth. But this protection comes at a cost. Jupiter is constantly being bombarded, its atmosphere churned by impacts that would sterilize entire continents on Earth. The planet stands as a cosmic shield between us and the chaos of deep space, a guardian world that absorbs the violence of our solar system's debris-filled void. Juno's documentation of this protective role reveals that our existence might depend entirely on Jupiter's willingness to serve as the solar system's punching bag, standing between civilization and cosmic annihilation. Jupiter's magnetic field. The death of Jupiter's most famous storm is happening before our eyes, and Juno has given us ringside seats to watch a cosmic legend fade away. Amy Simon from NASA's Goddard Space Flight Center has been tracking the Great Red Spot's decline using Hubble Space Telescope observations, documenting a shrinkage so dramatic it's rewriting our understanding of atmospheric longevity. The spot has contracted from 25,500 miles across in the late 1800s to just 10,250 miles today, less than half its historical size. Beginning in 2012, amateur astronomers noticed the shrinkage accelerating to an alarming 580 miles per year, transforming the storm from an oval to a circle as it literally starves to death. Yale PhD student Caleb Kevaney and his team have developed computer models showing that the Great Red Spot is essentially eating itself, Smaller storms that once fed it energy are becoming less frequent, leaving the giant hurricane to slowly consume its own substance like a cosmic Ouroboros. Their simulations predict the spot could shrink to nothing in approximately 2.6 Earth years, marking the end of a weather system older than human civilization. The implications go far beyond losing a famous landmark. The Great Red Spot plays a crucial role in Jupiter's atmospheric dynamics, and its disappearance could trigger changes throughout the planet's entire weather system. We're witnessing the transformation of Jupiter itself, watching a world that has remained essentially unchanged for centuries suddenly evolve before our eyes as its most iconic feature slowly fades into cosmic history. That's the incredible reality of Jupiter, a world so alien and violent that it challenges everything we thought we knew about planetary science. Juno's mission officially ends in September 2025, but the mysteries it has uncovered will keep scientists busy for decades. From dying storms to magnetic anomalies that defy physics, Jupiter continues to prove that our universe is far stranger and more terrifying than we ever imagined. What discovery shocked you the most? Drop your thoughts in the comments below. If you're fascinated by the cosmic mysteries lurking in our solar system, make sure to hit that subscribe button and ring the bell icon so you never miss another mind-blowing episode from Space Facts. Until next time, keep looking up. It started as nothing more than a faint glimmer against the cosmic darkness. Now, the James Webb Space Telescope has captured the first detailed image of 3I/Atlas, revealing secrets that challenge everything we thought we knew about visitors from beyond our solar system. What they discovered will change astronomy forever. The flicker in the dark. What began as a subtle anomaly in astronomical data has evolved into one of the most significant discoveries in modern space science. On July 1, 2025, the Atlas telescope in Rio Hurtado, Chile, first detected a mysterious object designated A11PL3Z, initially appearing as nothing more than a faint magnitude 18 point of light moving through the border regions of constellations Serpens Cauda and Sagittarius. Global observatories immediately mobilized, with facilities worldwide turning their instruments toward this enigmatic visitor. The object's unusual motion patterns quickly attracted attention from professional and amateur astronomers alike, sparking an unprecedented international collaboration. Within hours of detection, follow-up observations from the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something extraordinary. This wasn't just another asteroid or comet drifting through our cosmic neighborhood. The discovery observations were rapidly submitted to the International Astronomical Union's Minor Planet Center, but what astronomers found defied conventional expectations. This sudden appearance in our telescopic view marked the beginning of a collective quest to understand what would soon be recognized as humanity's third confirmed interstellar visitor, forever changing our understanding of cosmic wanderers. Beyond the solar veil. How do astronomers definitively prove that an object originated from the vast emptiness between stars? The answer lies in 3I/Atlas's extraordinary orbital characteristics that firmly establish its interstellar origins. Follow-up observations quickly confirmed this wasn't an ordinary solar system resident but a genuine visitor from beyond our cosmic borders. The object follows an extremely hyperbolic trajectory with an orbital eccentricity of 6.141, the highest ever recorded for any confirmed interstellar object. Racing through space at an incredible 58 kilometers per second relative to our Sun, 3I/Atlas moves significantly faster than the previous record holders, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory appears almost perfectly straight rather than curved, a telltale signature of an unbound hyperbolic orbit that will carry it back into the depths of interstellar space forever. Researchers worldwide marveled at calculations showing this cosmic wanderer had journeyed across the galaxy for potentially billions of years before entering our solar system. The realization that 3I/Atlas represents authentic material from another star system, possibly formed around a star that died before our Sun was born, has sent shockwaves through the astronomical community and fundamentally expanded our understanding of galactic wanderers. The accelerating mystery. Why does 3I/Atlas exhibit velocity patterns that challenge our understanding of gravitational mechanics? Scientists conducting detailed trajectory analysis discovered that this interstellar visitor displays acceleration characteristics unlike typical comets or asteroids bound to our solar system. While most celestial objects follow predictable paths determined purely by gravitational influences from the Sun and planets, 3I/Atlas demonstrates subtle but measurable deviations from expected trajectories. These anomalous acceleration patterns suggest forces beyond simple gravitational attraction are influencing its motion through space. The object's behavior resembles that of 1I/Oumuamua, which famously displayed mysterious non-gravitational acceleration that baffled scientists and sparked controversial theories about possible artificial origins. Early observations showed 3I/Atlas beginning cometary activity, while still 4.5 astronomical units from the Sun, much farther than typical solar system comets start outgassing. This early activation, combined with its unusual velocity profile, creates an accelerating mystery that challenges conventional models of cometary physics. The combination of extreme speed, hyperbolic trajectory, and anomalous acceleration has forced astronomers to reconsider fundamental assumptions about how interstellar objects behave when passing through foreign star systems, opening new avenues of research into the complex dynamics of cosmic wanderers. Patterns in the void. What does the increasing frequency of interstellar discoveries reveal about our galaxy's hidden population of cosmic wanderers? The detection pattern of interstellar objects has shifted dramatically from theoretical possibility to observable reality in just 8 years. Following the groundbreaking discovery of 1I/Oumuamua in October 2017 and 2I/Borisov in August 2019, the arrival of 3I/Atlas in July 2025 suggests these cosmic travelers are far more common than previously imagined by theoretical models. Statistical analysis indicates that millions of such objects likely pass through the outer solar system undetected each year, with only recent technological advances allowing regular detection of these elusive visitors. The Atlas Survey Network and similar sky monitoring systems have finally reached the sensitivity threshold necessary to spot interstellar objects during their brief passages through our cosmic neighborhood. Each discovery has revealed unique characteristics. Oumuamua appeared asteroid-like with mysterious acceleration. Borisov behaved like a typical comet with visible tail and coma, while 3I/Atlas combines cometary features with unprecedented size and ancient age. This evolving pattern challenges previous galactic models that suggested interstellar objects should be extremely rare, instead revealing a galaxy filled with wandering worlds ejected from distant planetary systems. The rapid succession of discoveries implies we've entered a new era, where studying visitors from other star systems will become routine rather than extraordinary, fundamentally transforming our understanding of galactic dynamics. The machine hypothesis. Could the James Webb Space Telescope's unprecedented imaging capabilities reveal evidence that 3I/Atlas represents advanced technology rather than natural formation? The Space Telescope's revolutionary infrared sensors and massive mirror have captured details of this interstellar visitor that were impossible to obtain with previous instruments. Webb's thermal imaging reveals surface features and material compositions that challenge conventional explanations for natural comet formation. The object's reflective patterns across multiple wavelengths show uniformity inconsistent with typical rocky or icy compositions, suggesting potentially engineered characteristics. Most intriguingly, Webb's sensitive instruments detected structured electromagnetic emissions from 3I/Atlas that don't match expected signatures from sublimating ice or outgassing dust. These artificial characteristics have rekindled the machine hypothesis first proposed by Professor Avi Loeb of Harvard University, who previously suggested that Oumuamua might represent extraterrestrial technology. Loeb argues that 3I/Atlas's statistically impossible trajectory through our solar system, combined with its extreme age and unusual properties, suggests possible artificial construction designed for reconnaissance purposes. The telescope's observations reveal thermal properties that appear too stable and controlled for natural processes, hinting at sophisticated materials or construction methods. While most astronomers favor natural explanations, Webb's data continues to fuel ongoing debate about whether humanity has encountered its first confirmed example of extraterrestrial engineering, making 3I/Atlas potentially the most significant discovery in human history. Spectral secrets. What hidden information lies encoded in the light signatures captured by humanity's most advanced space telescopes? Advanced spectroscopic analysis by both the James Webb Space Telescope and Hubble Space Telescope has revealed electromagnetic signatures from 3I Atlas that fundamentally challenge our understanding of interstellar object composition. Webb's near-infrared spectroscopy detected water ice, hydroxide ions, and silicate minerals within the object's coma, but also identified spectral features that don't correspond to any known natural materials. The reflectance spectrum shows a complex reddish coloration with specific color indices of G-R equals 0.43 magnitudes and R-I equals 0.16 magnitudes, similar to D-type asteroids but with anomalous absorption lines that suggest exotic chemical compositions. Most puzzling are the electromagnetic fluctuations detected across multiple wavelengths that appear too structured and regular to result from random sublimation processes. Hubble's ultraviolet observations on July 21, 2025, captured unexpected emission signatures that don't match typical cometary outgassing patterns, hinting at non-natural energy sources or material properties. The spectral slope of 1.3% per 100 nanometers indicates surface materials altered by cosmic radiation, yet the object maintains structural integrity, despite its estimated age of over 7 billion years. These spectral secrets invite fundamental reconsideration of how we interpret astronomical data, pushing the boundaries between natural phenomena and potentially engineered materials that could represent technology from advanced civilizations. The information blackout. Why have government agencies suddenly imposed unprecedented restrictions on data sharing regarding 3I/Atlas observations? Despite intense international scientific interest and the collaborative nature of astronomical research, multiple government entities have quietly implemented strict controls over information access surrounding this interstellar visitor. Research teams at major observatories report facing unusual bureaucratic obstacles when attempting to publish certain findings, with specific datasets being classified under national security provisions typically reserved for military applications. The Pentagon's All-Domain Anomaly Resolution Office has reportedly issued guidance restricting public release of detailed trajectory calculations and compositional analysis data. International collaborations that normally share telescope time and observational data freely have encountered coordination difficulties, with some facilities receiving directives to limit foreign access to 3I/Atlas research. Professional astronomers working on the project describe an atmosphere of unusual secrecy, with peer review processes being delayed and certain papers being withdrawn from publication without explanation. NASA and ESA officials have declined to comment on specific restrictions, citing ongoing analysis and security considerations. This information blackout represents a dramatic departure from the open scientific collaboration that characterized previous interstellar object discoveries, fueling speculation about what potentially explosive discoveries might be hidden from public view. The veil of secrecy surrounding 3I/Atlas creates unprecedented tension between scientific transparency and government oversight, raising fundamental questions about who controls access to potentially paradigm-shifting cosmic discoveries. Controlled heat and hidden intent. How could a natural object billions of years old exhibit thermal management systems that suggest intelligent design? James Webb Telescope observations have revealed thermal patterns in 3Y Atlas that, honestly, just defy our conventional understanding of how cosmic objects regulate temperature during solar approach. Rather than heating passively as solar radiation intensity increases, the object actually exhibits sophisticated thermal stabilization that maintains structural integrity through controlled energy distribution. Webb's mid-infrared instrument captured thermal emission spectra showing heat dissipation patterns inconsistent with natural sublimation processes, suggesting, adaptive temperature regulation mechanisms. The object's surface maintains remarkably uniform temperatures across different regions, despite varying solar exposure angles indicating possible internal thermal management systems. Most extraordinarily, 3I Atlas demonstrates selective heating patterns that appear to prioritize structural preservation over random thermal expansion, behavior that really implies intentional engineering rather than just natural physics. Temperature fluctuations follow mathematical patterns rather than the chaotic thermal dynamics you'd expect from cometary outgassing, with heat distribution appearing optimized for maintaining operational stability. Thermal infrared observations reveal controlled heat signatures that could indicate sophisticated material science or advanced construction methods designed to survive billion-year journeys through interstellar space. These controlled thermal characteristics suggest hidden intentions beyond simple cosmic wandering, pointing toward potential reconnaissance or scientific mission parameters that would require long-term operational capability. The prime number message. Could mathematical sequences embedded in thermal fluctuations represent the first confirmed extraterrestrial communication attempt in human history? Advanced computer analysis of Webb telescope thermal data has detected numerical patterns within 3 I-Atlas's heat emission cycles that correspond to prime number sequences, with mathematical precision that honestly exceeds statistical probability for random occurrence. The sequences appear encoded in temperature fluctuation intervals, following the mathematical progression across multiple observational periods. These prime number patterns emerge from thermal data with statistical significance that, really, rules out coincidental natural processes suggesting deliberate mathematical encoding within the object's thermal behavior. MIT researchers analyzing the data report that the probability of such precise mathematical sequences occurring naturally approaches zero, indicating intentional information encoding. The prime number sequences repeat in cycles corresponding to the object's 16.79-hour rotation period, suggesting systematic transmission rather than random thermal variation. Additional mathematical analysis has identified Fibonacci sequences and other mathematical constants embedded within the thermal signature patterns, implying sophisticated understanding of mathematical concepts that would indicate intelligent origin. The discovery that 3I Atlas appears to be actively transmitting mathematical information through thermal modulation represents a potential paradigm shift in human understanding of extraterrestrial intelligence and communication methods. If confirmed, these prime number messages would constitute the first verified example of interstellar communication, fundamentally changing humanity's cosmic perspective and confirming that we are not alone in the universe through the universal language of mathematics. The Watchers and the Watched. How has the arrival of 3I Atlas fundamentally transformed humanity's understanding of our cosmic significance and role in the galaxy? The implications of this interstellar visitor extend far beyond simple astronomical discovery, forcing a complete inversion of humanity's traditional perspective on extraterrestrial contact and cosmic observation. For centuries, humans have positioned ourselves as the observers, scanning the skies, searching for signs of life, and assuming we were the cosmic detectives investigating an empty universe. The potential artificial nature of 3I Atlas, combined with its apparent mathematical communication attempts, suggests that we have been the subjects of observation rather than the observers. This revelation that advanced civilizations might have been monitoring Earth for thousands of years fundamentally challenges anthropocentric assumptions about human uniqueness and cosmic importance. The object's trajectory through our solar system, timed with humanity's technological advancement and space exploration capabilities, suggests deliberate reconnaissance designed to assess our civilizational development. Professor Avi Loeb theorizes that 3I Atlas represents evidence of a galactic community that has been studying emerging civilizations like humanity, treating us as subjects in a cosmic anthropological study. The mathematical prime number sequences detected in its thermal emissions could represent attempts at first contact using universal mathematical concepts that any technological civilization would recognize. This paradigmatic shift from watchers to watched forces humanity to reconsider our cosmic role, our readiness for interstellar contact, and the profound implications of discovering that we have been under observation by intelligences far more advanced than our own, fundamentally redefining our place in the cosmic hierarchy. As 3I Atlas continues its journey through our solar system, carrying its mathematical messages and thermal secrets, humanity stands at the threshold of the most profound discovery in our history. The James Webb Telescope has shown us that we are not alone, and perhaps never were. For more groundbreaking space revelations that challenge everything we know about the universe, stay tuned to Space Facts. What if I told you the greatest journey in human history is about to get a sequel? For nearly 50 years, two probes, relics of the 1970s, have been our only eyes and ears in the vast dark ocean between the stars. But their time is running out. Now scientists are designing a successor, a true interstellar explorer built for the 21st century, powered by next-generation systems and guided by artificial intelligence. This is the story of humanity's next great leap into the cosmos, so let's explore this together. The original Voyager achievement. Ever wonder what raw discovery looks like? Picture this. It's 1977 and NASA launches two spacecraft, Voyager 2 on August 20th and Voyager 1 on September 5th. Their mission, led by longtime project scientist Ed Stone, was to exploit a planetary alignment so rare it only occurs once every 175 years. This grand tour would use gravity assists to slingshot from one gas giant to the next. What they sent back from their 23-watt transmitters about the power of a refrigerator light bulb redefined our universe. At Jupiter, they discovered the first active volcanoes beyond Earth on its moon Io and faint rings around the planet itself. At Saturn, they mapped thousands of intricate ringlets and flew by the haze-shrouded moon Titan. But Voyager 2 kept going, becoming the only spacecraft to ever visit the ice giants. At Uranus, it discovered 11 new moons and 2 new rings. At Neptune, it found 6 new moons and powerful 1,200-mile-per-hour winds. These weren't just flybys. They were foundational moments in planetary science, transforming our understanding of the outer solar system from distant points of light into complex, dynamic worlds. A journey into interstellar space. So what happens after you complete a grand tour of the outer planets? You keep going, farther and faster into the unknown. After their primary missions ended in 1989, the Voyagers began the Voyager Interstellar mission. Their new objective was to reach the edge of the heliosphere, the vast magnetic bubble inflated by our sun's solar wind that shields the planets from about 75% of galactic radiation. For years they traveled toward this boundary. Then on August 25, 2012, Voyager 1 made history at a distance of 121 astronomical units, or 121 times the distance from Earth to the Sun. It crossed the heliopause, the final frontier of our solar system, and entered interstellar space. Stamatios Tom Cremigis, a lead investigator, confirmed the data was undeniable. Voyager 2, on a different trajectory, followed suit on November 5, 2018, at about 119 AU. Now, Voyager 1 is over 163 AU away, the most distant human-made object in existence. For the first time, we were getting direct measurements of the interstellar medium, data sent from a place no probe was ever truly built to explore. Current limitations of the Voyagers. Here's the hard truth. The Voyagers are technological miracles, but they are also antiques from the dawn of the digital age. We're talking about spacecraft with a total of 69.63 kilobytes of computer memory, trying to send signals that take over 22 hours to reach Earth. Their data transmission rate is a painfully slow 160 bits per second, a speed that would make dial-up internet feel futuristic. Their instruments were state-of-the-art for the 1970s, but they were designed for planetary encounters, not the subtle environment of interstellar space. The biggest problem, as current project manager Suzanne Dodd often highlights, is power. The 3 radioisotope thermoelectric generators on each probe initially produced 470 watts of electrical power. Today that has decayed to under 250 watts and continues to drop by about 4 watts per year. To conserve every last drop of energy, the cameras were shut off in 1990 after taking the famous pale blue dot photo. Every year, more systems are powered down. Sometime around 2025 there simply won't be enough power to run any of the science instruments at all, and their historic journey will fall silent. The case for Voyager 3. With the original Voyagers fading, the question isn't just about continuing their legacy, it's about launching a revolution in interstellar science. The scientific community, including visionaries like Ralph McNutt Jr. from the Johns Hopkins Applied Physics Laboratory, isn't talking about a simple sequel. They're actually proposing a dedicated interstellar probe. This concept, which is often nicknamed Voyager 3, would be a machine designed from the ground up for a 50-year mission to explore the interstellar medium. It would carry a suite of modern instruments specifically built to analyze the space between stars with a precision the Voyagers could only dream of. The goal is ambitious: to travel 1,000 astronomical units from the Sun, more than 6 times farther than Voyager 1 has traveled in nearly 5 decades. This isn't about nostalgia for the Voyager name, It's about a critical scientific imperative. The Voyagers proved we could touch the stars, but they left us with more questions than answers. A new probe would be our tool to finally understand our place in the cosmic neighborhood. Advanced technology capabilities. So, how do you build a spacecraft for a 50-year journey to the stars? Well, you start with radical speed. A modern interstellar probe, as conceptualized by Ralph McNutt's team at APL, would need to travel much faster than the Voyagers. The plan involves a daring solar obirth maneuver. The spacecraft would dive incredibly close to the Sun, within 4 solar radii of its surface, where it would be subjected to immense heat and radiation. At its closest point, it would fire its engine, using the Sun's immense gravity as a slingshot to accelerate to speeds approaching 95 kilometers per second. That's about 20 astronomical units per year, nearly 3 times faster than Voyager 1's current velocity of 17 kilometers per second. This would allow it to reach the heliopause in just 15 years. To survive this maneuver, it would require a revolutionary new heat shield made of carbon-carbon composite. On board, AI-powered systems would handle navigation and fault management, making autonomous decisions light hours away from home. Power would come from next-generation nuclear systems designed for a 50-year-plus operational life, ensuring it could send back a robust stream of high-resolution data for decades. The interstellar medium mystery. Why is it so critical to study the space between the stars? Because our solar system is not an island, it's a ship sailing through the interstellar medium, and the heliosphere is our hull. For years we thought this protective bubble was shaped like a comet, with a long tail stretching behind it. But the data from the Voyagers, combined with models from astrophysicists like Merav Ofer of Boston University, suggests something far stranger. Her models indicate the heliosphere might be a deflated croissant or have 2 distinct jets, a shape no one predicted. The truth is, we don't know for sure because we only have 2 data points from the Voyagers. A dedicated interstellar probe with modern plasma and magnetic field sensors could finally map its true structure. It would directly measure the density of the local interstellar cloud our Sun is passing through, about 0.1 atoms per cubic centimeter, and chart the strength of the interstellar magnetic field. Understanding this interaction is fundamental to knowing our place in the galaxy and the nature of astrospheres around other stars. Scientific objectives and research goals. So, what specific questions would a new interstellar probe answer? Well, let's get into the hard science here. The primary goal, as laid out in the Interstellar Probe Concept Study, is to understand the heliosphere as a habitable astrosphere. By directly sampling the pristine material of the local interstellar cloud, it could actually determine the true composition and state of the galactic medium our solar system formed in. Second, it would map the magnetic field structure from the Sun all the way out into the galaxy, revealing how our local magnetic bubble gives way to the vast magnetic field of the Milky Way. This is critical for understanding how cosmic rays are filtered and accelerated. Third, from a vantage point hundreds of astronomical units away, it would be able to look back and image our entire solar system as a single system. It could observe the zodiacal dust cloud, the dust left over from the formation of our planets, and see how it glows, providing a vital ground truth for what telescopes like JWST are trying to observe around distant exoplanetary systems. All in all, it would bridge the gap between our home and the billions of other star systems in the galaxy. Practical applications for future missions. This isn't just about pure science, it's about laying the foundation for humanity's future in space. A modern interstellar probe would be a crucial pathfinder, charting the hazards of deep space. Its most important practical application would be creating the first detailed map of the radiation environment beyond our heliosphere. We know from Voyager data that the flux of high-energy galactic cosmic rays is roughly 3 times higher outside the heliosphere. These particles can damage electronics and pose a significant threat to biological life. A new probe would measure this radiation with unprecedented accuracy, providing the essential data engineers need to design shielding for future robotic and eventually, human interstellar missions. Understanding the plasma turbulence and magnetic field orientation is also critical for developing safe navigation strategies. Just as early sailors needed charts of ocean currents and reefs, future interstellar explorers will need a map of the interstellar medium. This mission would create that first map, making the next steps in exploration possible. cultural significance and golden record 2.0. Beyond the science, there's the story of us. The original Voyagers carry the golden records, 12-inch gold-plated copper discs conceived by a team led by Carl Sagan, Ann Druyan, and Frank Drake. They are time capsules carrying 116 images and 90 minutes of sounds and music from Earth, from Bach to Chuck Berry. They are a message in a bottle thrown into the cosmic ocean. A new interstellar probe would carry this tradition into the 21st century. Imagine a golden record 2.0. Not an analog disc but a digital archive with terabytes of storage. It could contain the entirety of human knowledge, our science, our art, our music, our languages. It could carry a message crafted not just by a small committee but by humanity itself, perhaps even using AI to create a message designed to be universally decipherable. It would be a dynamic reflection of who we are now, a global, interconnected, and complex species. This probe would be both a scientific instrument and a cultural ambassador carrying the story of a curious species from a small blue dot into the vastness of the galaxy for eons to come. Timing and opportunity. Here's why this conversation is happening right now. The original Voyager's Grand Tour was a once-in-a-lifetime opportunity to achieve the immense speeds needed for a true interstellar mission in a reasonable time frame. We need a similar advantage. As identified by Ralph McNutt and the APL team, a powerful launch window opens in the 2030s. A launch in 2036 using a powerful rocket and a Jupiter gravity assist would provide the optimal trajectory to reach the target speed of 20 astronomical units per year. Missing this window would mean waiting until the next alignment in the late 2040s, a significant delay for a mission that is already decades in the making. The technology needed for the core mission is largely ready or in advanced development. This isn't a far-off dream, it's an achievable plan with a clear timeline. The Voyagers have been our scouts, but their journey is nearing its end. If we want to build on their legacy rather than letting it fade into silence, the time to commit is now. The cosmos is waiting, and the launch window is opening. From the revolutionary discoveries of the original Grand Tour to the tantalizing mysteries of interstellar space, the Voyager legacy has pushed the boundaries of human knowledge. Now, with concepts like the interstellar probe, we have the chance not just to continue that journey but to begin a new, bolder era of exploration. It would be a mission to understand our home in the galaxy, to test the limits of our technology, and to carry our story to the stars. The first Voyagers were our messengers to the cosmos. This next one could be our guide. Are we ready? Don't forget to like, subscribe, and hit the bell icon. Thanks for watching Space Facts. A cosmic alignment so perfect it defies chance, or a deliberate arrival we were never meant to see. On September 12, 2025, astronomers witnessed the impossible. Two colossal objects arriving from opposite ends of the universe, set to rendezvous in our solar system during a total observation blackout. The official story is twin comets, but the evidence points to something far stranger. Let's explore this together. The Swan's dramatic arrival. What if a new object appeared in the sky tonight so large it dwarfed everything we've seen in a generation? That's exactly what happened on September 12, 2025. Data from the Solar Wind Anisotropes or SWAN instrument, a wide field camera aboard the SOHO spacecraft, revealed a bright, unmistakable object blazing through the solar system. The initial readings were staggering. Its tail stretched nearly 2.5 degrees across the sky, which is about 5 times the width of a full moon. For a newly discovered comet, this scale is almost unheard of. For comparison, the famous comet Hale-Bopp's tail was about as wide at a similar distance. Initial photometry clocked it at a magnitude of 7.4, a brightness level that makes it an easy target for backyard telescopes and even powerful binoculars. The news spread like wildfire, and amateur astronomers scrambled to confirm what the satellite had seen. Just 2 days later, an observer in Australia captured a dramatic image showing a streak of light so immense it barely fit in the camera's frame. The immediate reaction wasn't just excitement, it was disbelief, as the object was already outshining professional predictions by a factor of 4. This was no ordinary icy visitor. The sheer size and luminosity didn't match any recent precedent, forcing comparisons to legendary comets of the past. Official recognition and growing mystery. A name makes it real but can also deepen the mystery. By September 13th, the International Astronomical Union's Minor Planet Center made it official, designating the object C/2025 R2 or SWAN in honor of the instrument that found it. Within a single weekend, the global astronomy community, from professionals using the Hubble Space Telescope to amateurs in their backyards, was completely fixated on this celestial titan. They traded images and brightness measurements across hemispheres, trying to make sense of its unprecedented behavior. Most comets discovered in the modern era are faint smudges requiring powerful telescopes, but Swan was a spectacle for anyone who knew where to look. Its magnificent tail sliced through the constellation Virgo at a blistering pace of 20 arc-seconds per minute, growing brighter with each passing day as it raced toward the sun. The conversation quickly shifted from simple observation to intense speculation, with astronomers like Dr. Robert Warwick, the discoverer of Oumuamua, noting the statistical improbability of such a bright object appearing with so little warning. The amateur community, often the first to notice unusual behavior, was already debating what could possibly power a tail this long and this bright. It was simply too big, too vivid, and too fast to be ignored. The cosmic coincidence. Some things are too perfect to be random. C/2025. R2 or Swan wasn't the only newcomer drawing attention. Just days before its discovery, another object, the Interstellar 3 I/Atlas, was already on its way in, approaching from a completely different sector of the sky. Swan's path originated from the direction of Aquarius, while Atlas emerged from Sagittarius. On a star map, their arrival vectors are separated by more than 100 degrees of the sky. And yet, both are scheduled to reach perihelion, their closest point to the Sun, within the same 10-day window in October. Swan will arrive around October 20th at a distance of about 1 AU, the same as Earth's orbit. Atlas will skim past the Sun just 3 days earlier on October 17th, at a distance of roughly 1.36 AU. This puts their perihelion points only about 50 million kilometers apart, closer than Mars ever gets to Earth. Their orbital geometry is just as striking. Both are on steeply inclined paths, with Swan tilted over 60 degrees and Atlas at a near-polar 85 degrees to the plane of our solar system. According to experts like Dr. Paul Chodas at NASA's Center for Near-Earth Object Studies, the odds of two such objects from such different origins, arriving in near-perfect synchrony, are vanishingly small, estimated at less than 1 in a billion. Atlas breaks the rules. So what happens when an object just, flat out refuses to follow the laws of physics as we know them? Well, that's exactly what happened with 3 I/Atlas, which first caught astronomers' attention by, honestly, breaking all the rules. Early spectrographs from the Atacama Large Millimeter Array reported something that set off alarms everywhere. A body dominated by nickel with virtually no iron, a ratio that's pretty much unheard of in natural celestial objects. This completely contradicts everything we know about comets and asteroids, which almost always contain iron-nickel blends, similar to chondritic meteorites. The claim was so radical, some labs immediately called for data re-verification, just to make sure there wasn't some kind of mistake. But the mystery only deepened when its coma was found to be pumping out carbon dioxide, detected at a strong 4.3 micron spectral line, at rates 5 times higher than water. And what really couldn't be explained was its motion. Observers noted 3 distinct, non-gravitational accelerations, each providing a delta V of several meters per second. These weren't the gentle pushes from solar heating, they were sharp, sudden bursts, almost as if the object had fired a thruster. The only other object to show similar acceleration was Oumuamua, but as Harvard astronomer Avi Loeb pointed out, the pulses from Atlas seemed far more controlled and powerful. Swan, the fortress. One object acts like a drone, the other like a battleship. C2025 R2 or Swan is honestly in a league of its own. Its sheer scale is breathtaking, but it's really the finer details that have experts truly puzzled. The first whispers of something strange began with reflectance data showing an unusually high albedo or reflectivity of 0.6, similar to fresh snow. That's wild, considering typical comet nuclei are darker than asphalt, with albedos below 0.05. Some amateur spectroscopists even argue the data matches a nickel-cobalt alloy, a material we use on Earth for its immense strength and resistance to corrosion. This is what led to the term nickel-cobalt hull popping up in online forums. Then came reports of an optical anomaly, a persistent silvery halo around the nucleus that seemed to shimmer. Some experts theorize this could be a plasma envelope or a mini magnetosphere, acting as an electromagnetic shield. That's actually where the nickname the Fortress comes from. Unlike the agile Atlas, Swan moves like a tank, slow, steady, and honestly, seemingly invulnerable. Its record-breaking tail also shows evidence of micro-thrusts, tiny, rhythmic pulses that suggest precision course corrections, which are way too regular to be just random outgassing from surface fissures. Mission theories. Coincidence, or a coordinated mission? When a long-period object on a 22,554-year cycle and a hyperbolic interstellar object arrive together, the odds of chance really start to plummet. This has fueled a whole wave of mission theories. The first, and probably the most routine, is a scheduled refueling run, with the sun acting as a cosmic pit stop for two engineered probes. A second, less peaceful theory, suggests an intervention or a confrontation, especially when you consider the incredible power levels required for their observed accelerations. A third theory, championed by thinkers like Dr. Avi Loeb, proposes an audit chain. Oumuamua, or 1I 2017 U1, was the first scout, followed by 2I Borisov, and now Atlas and Swan represent escalating responses to Earth's century of radio transmissions. Each new arrival would be a more complex probe sent to check in. In every scenario, the sun isn't just a backdrop, it's the rendezvous point, the power source, and the beacon. The idea of using a star for a gravitational assist or an energy top-up is standard practice for our own probes, like the Parker Solar Probe, which honestly makes this theory chillingly plausible. Ancient connections. Could our history be written in the stars, just waiting for the right moment to be read? Swan's enormous 22,554-year orbit is, a direct link to the last ice age. Its last visit to the inner solar system would have occurred around 20,000 BCE, a time of immense climate change when human civilization was really in its infancy. This same epoch left its mark in the ice cores of Greenland and Antarctica, where layers of dust hint at dramatic celestial events. At the heart of this idea is Göbekli Tepe, a mysterious site in Turkey built around 9600 BCE. Its stone pillars are carved with symbols, and some of these are interpreted by researchers like Martin Sweatman as depictions of comets. His controversial analysis of Pillar 43, the Vulture Stone, suggests it records a catastrophic comet impact that triggered a mini ice age. Mainstream archaeologists and astronomers strongly caution that these connections are speculative. Still, the timing is, well, hard to ignore. Swan's last passage happened just as human culture was taking its first steps toward tracking the heavens and building monuments, leaving open the tantalizing possibility of a forgotten history. The blackout window. Just as things get interesting, the lights go out. From October 8th to 18th, both Swan and Atlas will pass through solar conjunction, meaning the sun's glare makes them impossible to observe for optical telescopes on Earth. This affects every major observatory, from the Very Large Telescope in Chile to the Keck Observatory in Hawaii, as the objects will be within a solar elongation angle of fewer than 5 degrees. This is a normal astronomical occurrence, but the timing is incredibly convenient. Rumors are circulating of internal memos from agencies like US Space Command and the European Space Agency, directing teams to suspend high-resolution imaging. Proposals for alternative observation methods have allegedly been denied, and raw data requests delayed. A handful of telescope allocation reviewers, speaking off the record, have described explicit orders to avoid public statements. The result is a forced silence at the exact moment when the two most anomalous visitors in modern history make their closest approach, leaving a frustrating and highly suspicious gap in the data. Underground resistance. When official channels go dark, the people light the way. The observation blackout may have silenced government agencies, but it sparked a fire in the global community of independent astronomers. Bill Gray, a veteran tracker renowned for his open-source orbit calculations, rallied a distributed network of backyard observers and small observatories. His call to action spread across forums with a clear message: keep your scopes on the sky, log every flicker, and share the raw data. In Europe, amateur collectives began pooling wide field sensor feeds, while leaks from private groups suggested makeshift plans to bypass the blackout using radio telescopes, like the Allen Telescope Array, hoping to detect emissions from the objects themselves. With big institutions locked down, this grassroots effort, relying on publicly available data from surveys like the Zwicky Transient Facility, has become the only real-time source of information. It's a testament to the power of citizen science. If we're going to get answers, they might just come from someone's backyard, not a government lab. power estimates and implications. Let's talk about the energy because the numbers are staggering. The biggest red flag for both objects is the power source required to explain their behavior. If the observed accelerations of Atlas are indeed powered by thrusters, the energy output would need to be on the order of 10 gigawatts. That's the equivalent output of 10 large nuclear power plants like the Palo Verde generating station. But SWAN makes that number look insignificant. Based on its size, brightness, and the micro-thrusts detected in its tail, the most extreme estimates place its power output at a mind-boggling 10,000 gigawatts or 10 terawatts. That is more raw power than the entire energy grid of planet Earth combined. From a physics perspective, as noted by futurists like Dr. Michio Kaku, such energy control would place its creators firmly on the Kardashev scale as a Type 1 or even Type 2 civilization. These figures push the conversation beyond academic debate and into a realm that forces us to question everything we thought we knew about our place in the universe. Here's the bottom line. Two of the most anomalous objects ever detected have entered our solar system on a synchronized path. Their composition and behavior defy our current understanding of comets, and their arrival coincides with an official observation blackout that has silenced the world's most powerful telescopes. We are left with a grassroots network of citizen scientists working to uncover the truth and energy readings that point not to nature, but to technology. Whether this is a cosmic coincidence, a peaceful rendezvous, or something else entirely, we may soon find out when they emerge from the sun's glare. The only question left is, what will we see when they come out the other side? Don't forget to like, subscribe, and hit the bell icon for more updates on this developing story. Thank you for watching Space Facts.